want you to do something for me. Just right now. Hold up your hand. Look at it. Now look past it. Look at the walls of the room you're in, the floor, the ground beneath your feet. It all feels real, doesn't it? It feels solid, substantial.
It's the only thing our senses are built to understand. It's our brain's default setting. This is reality.
Exactly. And I need you to understand before we go any further, that feeling is, well, it's a complete hallucination.
It's a profound selection bias. It's like looking for your lost keys, but only under the one street light on the block, just because that's where the light is.
You drop them in the dark 100 yards away.
And you're never going to find them.
We are living with a fundamental delusion of significance. Because if you could pull back, and I don't just mean a few feet, I mean zoom out until our entire galaxy is just a little smudge of light. Everything you've ever seen, ever touched, every person, every star, every planet, it's just foam.
Bioluminescent foam. It's really the only image that does it justice.
That's the image I can't shake. You're on a boat in the middle of the ocean at midnight, no moon. The water is black, deep, endless. And on the very top of the waves, you see this thin, glowing film of algae.
Just this delicate, fragile scum floating on the surface.
That's scum. That's us. That's the entire visible universe. Every proton, neutron, and electron. That's all of it.
And the ocean. The vast, cold, dark ocean underneath.
That's 85% of everything. 85% of the mass of the cosmos. We call it dark matter.
Which is, frankly, a terrible name for it.
It's a marketing failure, isn't it? It makes it sound like it's just some other kind of stuff, hiding in the corner.
Like it's an accessory to the universe. It's not. It is the universe.
Yeah.
The deep, crushing pressure of that invisible ocean is the reality.
And we are the contamination.
We're the glitch. A 15% rounding error. Our kind of matter, this baryonic stuff that makes up you and me in this table, it's a minor impurity in a cosmos that was clearly built for something else.
And that something else, it doesn't talk to us. It doesn't see us. It doesn't interact with us in any way we can comprehend except for one.
Gravity.
Gravity. It's the only language the ocean speaks. And for the better part of a century, the ocean has been screaming at us. And we've just been trying to find ways to pretend we don't hear it.
Because the message is deeply unsettling.
The message is that the floor you're standing on isn't real. So that's how we have to approach this. This isn't just physics. It's a crime scene.
It's a noir investigation.
Exactly. Our whole concept of reality is the victim, and the culprit is the universe itself. We're the detectives, showing up late, looking for clues. And the very first clue, the thing that told us something was fundamentally broken, was just watching how things move.
The kinematics of the cage.
Just motion. That's it. We have rules for motion. They feel intuitive. We understand them in our bones.
They feel sane.
Yeah.
It's Kepler's laws. It's Newton. In our solar system, for instance, everything makes perfect sense. There's a direct, unbreakable link between how far you are from the sun and how fast you have to go.
The sun is the anchor.
It's the anchor. 99.8% of all the mass in the system is in that one star. So if you're close to it, you're feeling an immense gravitational pull.
Like Mercury.
Right. Mercury has to absolutely haul just to stay in orbit. It's moving at 47 kilometers a second. If it went any slower, it would just fall into the sun.
It's running for its life.
It is. But then you go way, way out to the edge, to Neptune.
Out in the cheap seats.
Way out there.
Yeah.
The sun's grip it's a whisper. It's incredibly weak. So Neptune can't go fast. If it moved at Mercury's speed, it would have flown out of the solar system billions of years ago. It wouldn't even be close.
It moves slow, a nice leisurely pace.
Just 5.4 kilometers a second. This is what we call the Keplerian decline. The further you get from the center of mass, the slower you go. The graph curves down. It's sensible.
It's a rule. And for the longest time, we just assumed that rule applied everywhere. We looked out at these giant, beautiful spiral galaxies like Andromeda.
These huge pinwheels of light.
And we saw the same thing, a bright, dense center where most of the stars are, where most of the light is. So that's where the mass should be.
That's the anchor.
So the stars way out at the edge in the dark, lonely suburbs of the galaxy. They should be moving slowly. They should be like Neptune.
Just drifting along. Barely hanging on. That was the assumption. That was the sane model of the universe.
And then somebody actually went and looked.
They measured it. In the 70s, astronomers like Vera Rubin and Kent Ford pointed their telescopes at the edges of galaxies. They looked at the faint gas clouds way out past where the starlight gives out. They were expecting to see that graph curve down.
They were expecting Neptune.
They were.
And what did they find?
The line went flat.
What does that mean, flat?
It means the stars at the edge weren't slowing down. A star 50,000 light-years from the galactic center was moving at the same incredible speed as a star right in the middle.
That doesn't make any sense.
It makes no sense at all.
Let's try to picture this. Think of a race car. A Formula One car on a flat track coming into a sharp 90-degree turn. Physics has a speed limit for that turn. You go too fast.
The tires lose their grip. Friction isn't strong enough. You don't make the turn. You fly off the track in a straight line.
You crash. It's inevitable.
It's basic centripetal force. There's not enough force pulling you toward the center to change your momentum.
Okay, now imagine you're watching that car. It hits the turn doing 200 miles an hour. It doesn't slow down, and it doesn't crash. It just turns like it's locked into a groove, as if it's on rails.
Perfectly smooth. What would you conclude?
I'd have to assume something was helping it, something I couldn't see.
Like what?
Like maybe the track isn't flat, maybe it has a super steep invisible banking that's pushing the car in.
An invisible banking. Or an invisible wall. And that's exactly what those flat rotation curves were screaming. These galaxies are spinning so fast they should be tearing themselves apart.
The stars at the edge should be flying off.
They should be flung out into the void. The gravity of the stars we can see, the visible matter, it's not even close to being strong enough to hold on to them. It's like trying to hold on to a cannonball with a piece of sewing thread.
But they're not flying off.
They're being held in a vise. There's an invisible wall of gravity holding them in. An invisible cage.
That's the feeling I get from this. It's not a cozy force holding things together for our benefit. It's a sensation of confinement, the invisible glass.
It's absolutely a cage. What we see when we look at a galaxy, that beautiful spiral disk, that's just a tiny bit of glowing dust in the very center of a colossal invisible sphere. A halo.
So the halo is the real structure.
The halo is the reality. The visible part is just a small condensation, like breath on a window pane. And this halo of dark matter is maybe 10 times wider than the visible galaxy and 10 times more massive.
So the stars aren't holding the galaxy together.
Not at all. The stars are prisoners. They're trapped inside this sphere of invisible mass, and its gravity dictates their speed.
We're moving at 220 kilometers a second around the Milky Way, not because of the suns we can see.
But because the cage demands it. The invisible mass is whipping us around. If you could magically snap your fingers and make all the dark matter disappear, the Milky Way would dissolve in an instant. The stars would just scatter into the darkness.
It's the only thing holding us together. But, and this is where the story gets even stranger, we don't even seem to know how thick the bars on our own cage are.
You're talking about the Gaia data, the uncertainty.
Yes, this felt like a plot twist, the last-minute piece of evidence thrown on the detective's desk.
It's very new. The Gaia Space Telescope is mapping our galaxy, the Milky Way, in unbelievable detail, its position and velocity for billions of stars. And some of this new data seems to show that if you look at the very, very outer edge of our galaxy, the speed, it actually does start to drop off.
Wait, so the Keplerian decline? It might be happening here, in our own backyard.
It might. Some scientists are now arguing that the Milky Way's dark matter halo is much lighter than we thought, that our specific cage is thinner, more fragile.
What's that mean?
It means we might be an outlier. And it's causing a huge fight in the community. Is the data right? If it is, it might challenge some of our bigger cosmological models. Or is the data just noisy? Are those outer stars just wobbling from some ancient collision?
For me, that just makes the dread worse. It's one thing to be in a prison. It's another thing to be in a prison and not even know the dimensions of your own cell. We're trying to weigh the walls from the inside.
And all of this, everything we've talked about so far, it's just circumstantial evidence.
It's just kinematic. Things are moving weird.
Exactly. And a skeptic could, and did, come along and say, well, maybe you just don't understand gravity. Maybe Newton's laws need a little tweak over vast distances.
So it's MOND, right? Modified Newtonian dynamics.
That's the idea. There's no invisible stuff. The rules just change when you get to a galactic scale. It's an elegant idea.
It's a comforting one. It means the universe is still just us. What we see is what we get. We just need a better calculator.
It's very comforting. And it's almost certainly wrong. Because we found the body.
We found the smoking gun.
We have a picture of the ghost leaving the machine. We need to talk about the bullet cluster.
Okay, so if the rotation curves were the strange footprints at the crime scene, this is the blood on the walls. This is the undeniable proof.
The bullet cluster isn't a single object. It's the aftermath of a cosmic car crash. It's what happens when two entire clusters of galaxies, each containing hundreds of galaxies, slam into each other at millions of miles per hour.
A collision on an unimaginable scale.
And it's the perfect laboratory, because it allows us to pull the components of the universe apart and see what they do in a crash. A galaxy cluster is made of three main things.
Let's break them down. Component 1, the galaxies themselves. The little islands of stars.
Okay, so the galaxies are mostly empty space. A star is a tiny point of light, and the distance between stars is vast. So when two galaxies collide, the stars themselves almost never actually hit each other.
They just pass right through.
Like two handfuls of sand thrown through each other. They just fly past. So in the bullet cluster, the individual galaxies sailed right through the collision and kept on going. They're on the other side now.
Okay, so the bodies keep moving. What's component 2?
The gas. Every cluster is filled with a huge hot cloud of intergalactic gas, the intercluster medium. And this gas makes up way more of the normal baryonic matter than the stars do, maybe 10 times more.
And what happens when two giant clouds of gas hit each other at supersonic speeds?
They don't pass through each other. Gas has friction, it interacts, it's like two tsunamis colliding. They slam together, create a massive shock wave, and stop dead in their tracks.
So in the middle of this collision, you have this huge pileup of hot gas.
Exactly. It gets superheated and glows brightly in X-rays. It's shaped like a bullet, which is where the cluster gets its name. So you have the galaxies that pass through, and you have the gas that's stopped in the middle.
Which brings us to component 3, the mystery. Where is the gravity?
This is the crucial question. If there's no dark matter, if MOND is right, and gravity is just a property of the normal stuff we can see, then the center of gravity should be where the center of mass is.
And the mass is the gas. It's 10 times heavier than the stars.
So the gravity should be locked onto that big hot pile of gas in the middle. The pull should be coming from the center of the crash.
But it isn't.
It isn't. We can map gravity. We can see where it is by using a technique called gravitational lensing.
How does that work? How do you see an invisible force?
Mass warps space-time. It's like putting a bowling ball on a trampoline. And light follows that curve. So we look at galaxies that are far behind the bullet cluster. As their light travels towards us, it gets bent by the gravity of the cluster. By measuring how much the light from those background galaxies is distorted, we can create a map of where the mass is.
You can weigh the bowling ball by seeing how much it sags the trampoline.
Precisely. And when they made that map of the bullet cluster, the gravity wasn't with the gas.
Where was it?
It was with the galaxies. The lensing map showed two big clumps of mass on either side of the crash, right where the galaxies had passed through. The hot gas was in the middle, but the gravity had kept on going.
This gives me chills. The ghost. It detached itself from the body.
That's exactly what happened. The dark matter, making up 85% of the total mass, is just like the stars. It's collisionless. It doesn't feel friction. It doesn't interact. So it just sailed right through the crash, silent and indifferent, carrying the galaxies along with it.
So you have this horrifying picture. The physical matter, the gas, the blood of the collision is left screaming and burning in the center. But the gravity, the actual soul of the thing, has just walked away from the wreckage.
It's like watching a person run into a wall. Their body stops, but their shadow keeps going, right through the wall to the other side. And the shadow weighs 5 times more than the person.
That proves it. It's not just that gravity is acting weird. It proves that gravity is coming from a thing, a substance that can be in a different place than our matter.
It kills the MOND hypothesis in one shot. Because if it were just modified gravity, the gravity would have to stick with the matter. Here, the gravity is physically separated.
You can almost hear it.
You can, actually. They've done sonifications of the data.
What does that mean?
They assign sounds to the different data sets. They took the X-ray data from the hot gas, the crash, and mapped it to how frequency sounds. Then they took the lensing data, the dark matter map, and mapped it to low, deep frequencies.
And what does it sound like?
The gas is a high-pitched, violent screech. It really sounds like tearing metal in chaos. It's the sound of the accident. It's noise.
And underneath it.
Underneath it all is this deep, powerful, resonant hum. It's almost a silence, but it's a heavy silence. And you realize, listening to it, the silence is heavier than the scream. The power isn't in the noisy crash. The power is in the deep, silent hum that just passes through, completely untouched.
The dark matter is the tide. We're just the noisy debris floating on top.
And that tide has a structure. It's not just a random ocean. If you zoom out even further, way past the bullet cluster, you start to see the architecture of the whole thing. The universe isn't a random collection of stuff. It's a web.
The scaffolding. This is the next level of the investigation, the grand design.
If you could put on dark matter glasses and look at the cosmos, it wouldn't look like scattered points of light. It would look like a three-dimensional spider web, or a network of brain cells, or the mycelial network of a fungus.
So what are the parts of this web?
You have vast, thick filaments of this invisible matter stretching for hundreds of millions of light years. These are the threads of the web. And where these filaments cross, you get these huge, dense nodes. And in between all the filaments,
The voids.
gigantic, almost perfectly empty bubbles of expanding nothingness. It's like a cosmic sponge. Most of the universe is actually these voids.
So where are we? Where's the Milky Way in all this?
We're in one of the filaments. We are living on one of those strands of silk, being pulled slowly toward a massive node called the Virgo supercluster.
We're caught in the web.
But here's the crucial point. We didn't build this web. We fell into it. This structure was in place long before the first star ever ignited.
How is that possible? This goes back to the very beginning, doesn't it? The moments after the Big Bang.
The very beginning. The universe was a hot, dense, uniform soup of particles and radiation. Now, our kind of matter, baryonic matter, it couldn't get started. It couldn't clump together. The radiation pressure was too high. It was like trying to build a sandcastle in the middle of a hurricane. Every time gravity tried to pull a few protons and neutrons together, a blast of high-energy photons would just blow them apart again.
We were too light, too fragile, blowing in the wind.
Exactly.
Mm-hmm.
But dark matter, it has a secret weapon.
It ignores light.
It ignores the hurricane completely. It doesn't interact with photons. So while all of our matter was being tossed around in this chaotic storm, the dark matter was just quietly collapsing under its own gravity. It was digging the foundations.
It was building the web.
It was building the gravitational scaffolding of the universe. It was creating these deep gravitational wells, these filaments, these nodes, while our matter was still just a featureless fog.
And then eventually the universe expanded and cooled.
And the hurricane died down, the radiation pressure dropped, and for the first time, our matter could finally feel the pull of gravity without being blown apart. And where did it go?
It fell into the holes.
It fell into the traps that the dark matter had already set. It had no choice. It pooled into the deepest parts of those filaments, into the bottom of those gravitational wells.
That's where the galaxies formed.
That's the only reason galaxies exist.
No.
Without that pre-existing dark matter scaffolding, our universe today would just be a thin, uniform, featureless mist of hydrogen and helium. No stars, no planets, no people. We owe our very existence to this invisible structure we can't see.
So it's like a Christmas tree.
That's the best analogy. The dark matter web is the tree, the branches, the trunk, the shape. That's the reality.
And the visible universe, the galaxies, the stars.
We're just the decorative lights. We're the glitter someone's sprinkled on the branches. And for all of human history, we've been staring at the pretty lights, thinking that's the whole picture. We didn't even know there was a tree underneath.
And now that we have a new telescope, a better way of looking at those lights, we're starting to see that some of them aren't just lights. Some of them are monsters.
This is the crisis. The James Webb Space Telescope, JWST.
It was supposed to show us the baby pictures of the universe.
It was supposed to confirm our models. We expected it to look back to the cosmic dawn a few 100 million years after the Big Bang and see tiny, messy, infant galaxies slowly coming together. A bottom-up process. Small things merge to make big things.
But that is not what it saw.
Not all. It looked back into the primordial darkness, and it found fully formed monsters.
The blue monsters.
Galaxies that appear to be as massive and mature as our own Milky Way, but existing at a time when there shouldn't have been nearly enough time or matter to build them. They're too big, too bright, too early.
It's like building a skyscraper in a weekend. It violates the known laws of cosmic construction.
It's thrown cosmology into a state of, well, controlled panic. The standard model might be broken, the universe might be older than we think, or there's a third option, a much darker one.
One that connects back to the ocean.
What if we're not looking at what we think we're looking at? What if those bright blue dots aren't galaxies at all?
What are they then?
What if they're stars?
Single stars. How can a single star be as bright as an entire galaxy?
Because it's not powered by a normal engine. Our sun runs on nuclear fusion, smashing hydrogen into helium. This is a different kind of engine. This is a dark star.
Powered by what?
Powered by dark matter annihilating itself.
Okay, you have to walk me through that.
A leading theory is that dark matter particles are their own antiparticles. So if you get two of them together, they annihilate each other and release a burst of energy.
Okay.
Now, imagine the early universe. A huge primordial cloud of hydrogen gas starts to collapse into one of those deep dark matter wells we talked about. The gas gets denser, but the dark matter at the core gets incredibly dense too. So dense that the dark matter particles start hitting each other and annihilate.
They start eating themselves.
And releasing enormous amounts of energy. This energy, this heat, pushes back against the collapsing gas cloud. It stops it from collapsing all the way down to form a normal star. It puffs it up.
How big would a star like that be?
Unfathomably huge. We're talking about a single star that could be the size of our entire solar system. 10 astronomical units across. One single object that would stretch from our sun out past the orbit of Saturn.
A single star the size of a solar system.
Cool, diffuse, and puffy. And because of its immense surface area, it would be as luminous as an entire galaxy of normal stars.
So JWST might not be seeing the first galaxies. It might be seeing the first things. The first ovens of the universe, powered by the dark sector burning itself to create light.
It's a terrifying, beautiful idea. And it's not the only monster JWST is finding.
The little red dots.
These tiny points of light that seem to be supermassive black holes. But again, they were too massive, too early. They seem to be growing much, much faster than physics should allow.
There's a speed limit for eating, right? The Eddington limit. A black hole can only swallow so much matter before the radiation from the meal itself physically pushes the rest of the food away.
Exactly. You choke on your own light. But these things are just gorging themselves, growing at super Eddington rates, and the implication is chilling.
The dark matter halo isn't just a passive cage.
It's a feeding tube. It's actively funneling gas and matter into the mouths of these primordial black holes, force-feeding them at rates we can't explain. The dark universe isn't just our house, it's actively growing monsters in the basement.
This is where we have to shift from the physics to the philosophy, from the what to the so what. We have the invisible glass cage, the ghost in the machine, the cosmic spider web, the dark stars. What does it all mean for us? What are we in relation to them?
Now we have to get speculative. Now we move into sci-fi horror, but using these ideas as plausible theories. And the first thing you have to confront is the ratio, 85% to 15%.
It changes your perspective on who owns the place.
Completely. We act like this is our universe. We map it, we name it, we plan to colonize it. We're not owners, we're squatters.
And the landlords don't even know we're here. Or maybe they do.
That's the truly terrifying thought. What if the dark matter isn't just inert, invisible rocks? Why should it be? It has gravity, structure, energy. Why couldn't complex systems evolve within the dark sector?
What if it's alive?
This is the idea of the Photino birds, from the writer Stephen Baxter. He imagined a form of life made from dark matter particles, and he took the ratio to its logical conclusion. If they are 85% of the universe,
they're the dominant species. They're the default citizens.
And we are the minority. We're the anomaly. We are, from their perspective, baryonic filth. A noisy, hot, light-emitting pest that infests their nice, cold, clean gravity wells.
So they're not evil, they're just doing pest control.
Exactly. In his stories, they don't hate us. Yeah. They're just tidying up. They see stars as a kind of pollution, a contamination of their dark universe. So they engineer ways to put them out. They are cosmoforming the universe to make it more comfortable for the majority.
And a universe that's comfortable for them is a dead, dark universe for us.
In a war between the 15% and the 85%, the outcome is mathematically certain. We're the termites in the walls of a house we don't even realize we're living in.
But there's another idea. Maybe it's not that they're alive. Maybe it's that they're dead.
This is the ruins concept. You see it in writers like Liu Cixin. It connects to ideas from string theory, that the universe might have more dimensions than the three we perceive.
So dark matter is invisible to us because it's somewhere else.
Or maybe it's just flat. Imagine the universe began with, say, 10 dimensions, a paradise. But at some point in the distant past, ancient civilizations went to war. And their ultimate weapon wasn't a bomb, it was a dimensional strike.
An attack on reality itself.
They found a way to collapse dimensions, to take a volume of 3D space and flatten it into a 2D plane, like running over a cardboard box with a steamroller.
It becomes invisible to us. It has no thickness.
It has no thickness, but it still has mass. It still has gravity. What if dark matter is the wreckage of that war? What if the universe is filled with the flattened 2D corpses of destroyed regions of 3D space?
So we're not living in a house, we're living in a graveyard.
We are walking through the gravitational tombstones of a higher reality that was murdered long before we were born. The invisible pull we feel from the galactic halo isn't a cage built by a living thing. It's the weight of a ghost, the rubble of a lost dimension.
That explains the cold and the silence.
It recasts the whole story.
Yep.
We're not squatters, we're survivors, picking our way through the ruins of a war we can't even comprehend.
Or the third option, the most abstract one. It's not life, it's not death, it's a mistake.
It's a glitch in the code. The idea that the laws of physics aren't perfectly uniform, that dark matter is just a region of space-time where the math is different, a fundamental defect in the operating system of the cosmos.
All three of those paths lead to the same feeling, utter insignificance.
Which brings us full circle, back to the beginning of the investigation, back to the denial, the Zwicky gap.
Right. We have to talk about the silence. Not the silence of space, but our silence.
For Zwicky. In 1933, he looked at the Coma Cluster of galaxies. He saw they were moving around way too fast. He did the math and said, for this cluster to hold itself together, there must be hundreds of times more mass here than we can see. He called it dunkel materie, dark matter.
1933. And what happened?
Nothing.
He was ignored.
Completely. For 40 years, nobody wanted to touch it. It wasn't until Vera Rubin's work on rotation curves in the 70s that the community was finally forced to confront it. Why? Why the 40-year gap?
It wasn't a physics problem, it was a psychology problem.
It was sociology. It was hubris. We did not want to admit that we don't matter. We are creatures of light. Our eyes see light. Our telescopes see light. We wanted to believe that the universe was made of light and things that reflect it.
To accept dark matter is to accept that light, our primary sense, is irrelevant to the vast majority of the universe.
It's to accept that we are irrelevant. It's the ultimate Copernican demotion. First, we weren't the center of the solar system. Then our solar system wasn't the center of the galaxy. Then our great galaxy was just one of billions. This is the final step. Not only are we not in the center, we're not even made of the right stuff.
We would rather live in a universe that was wrong, but where we were significant, than a universe that was right, but where we were just foam.
But the universe doesn't care about our ego. The data is what it is. The rotation curves are flat. The ghost walked through the wall. The web was built before we got here.
So where does that leave us when you walk outside tonight and you look up at the sky at the Milky Way? What are you really seeing?
You are seeing the distraction. You are seeing the beautiful, luminous 15% contamination.
And the blackness between the stars.
That's the ocean. That's the reality. And it's holding you. That an invisible glass is the only thing keeping your galaxy from flying apart. That invisible web is the reason the sun was ever born.
The void is staring back.
And it is very, very heavy. It passed right through us in the bullet cluster. It built our house for us in the beginning. And it outnumbers us 5-1 in our own home.
We are alone in the light.
But we are surrounded in the dark.
You can almost feel the weight of that silence.
Try to. It's the sound of the real universe.